Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Run-on-Nabner Loop by GDC. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Loop. Draw a one cell wide loop through the centers of some cells. The loop cannot touch itself, not even diagonally. So, for example, let's see. Well, okay. For a loop, it has to touch. It has to go through the center of cells. So it actually can go diagonally then. So it doesn't actually, does it? Hold on, let me pause and see if this is actually the case. Okay, from the example that's given, I think this actually cannot actually. I think the loop actually has to touch itself orthogonally. It doesn't actually specify. You could actually technically have a loop which goes diagonally through the center of cells. But that actually is not. That's very. I don't think I've ever seen a loop drawn that way. Usually loops have to orthogonally connect. It has to be an orthogonally connected loop, which means that they have to share a border to be a functional loop, right? So this would be a valid loop, but the question I'm having is whether you can take this out and then basically that is a valid loop. Usually it's not, but this doesn't say it has to be orthogonally connected, which is kind of weird. One thing it cannot do though is touch itself diagonally. So it could not be something along the lines of like this, right? First of all, because it would touch itself diagonally in multiple positions. But yeah. So this is touching itself diagonally then. So this is not possible. Um hmm. Yeah, I'm not sure if it has to be orthogonally connected completely through the loop. It potentially could do something like this, right? That technically is a loop. Uh, we'll have to read more of the actual rules to see if we can rule that out. But I've never seen this actually as a rule set here. That this would be valid. Anyways, let's see what other rules there are. Run-on-Nabner. Digits that are 1, 2, 3, or 3 steps apart on a loop differ by 2 or more. For example, if there is a 4 on the loop, the 6 surrounding cells on the loop, the next 3, and the next 3 and the previous 3 can't include 3, 4, or 5. So I hope that makes sense. Basically, for every cell on the loop, the 3 cells preceding and the 3 cells after that are on the loop cannot conclude digits that are less than 2 steps apart. So they can't be the same as the loop. So this could not anything that's 3 away. So this could never be a 4 then on this loop if this were a valid loop. But you could also not have a 3 or 5. You can't have anything consecutive. So you can't have repeats or things that are or digits that are consecutive with it that are 3 away on the loop. That are up to 3 away, right? So none of these can contain 3, 4, 5, if that's the case. None of these could be 3, 4, 5 if that's the case. Say this was a 7. If this were a 7, none of these 3 digits could be 6, 7, or 8, because again, you can't have a 7, and that's why it's Run-on-Nabner. Nabner is essentially, you can't have consecutive digits, and you can't have repeats on there. So this cannot have a 7, it cannot have a 6 or an 8, because those are consecutive. These 3 cannot have a 7, and they can't have a 6 or an 8. It's basically the previous 3 on the loop and the next 3 on the loop cannot be consecutive or be the same digit. And that's Run-on-Nabner. Internal xsums. A digit n in a cell containing a number x in its top left corner is on the loop. Okay, so another reason why this doesn't work as a loop is that every cell with a number in the upper left corner is on the loop. And the digit in that cell indicates that the cell sees n loop cells in the row and column combined, including itself, and that those digits sum to x. Non-loop cells block vision. Okay. So, for example, this cell would have to see 5. So therefore, it would be 5. Because they are an internal x cell. So therefore, it would say this is it sees 5 digits, right? That are on the loop. And it does not see this one, because it's blocked by a non-loop cell. So this would be saying this is 5 digits that it sees, and it would have to add up to 21, right? This one would be, this sees 7, and it would have to add up to 16, but obviously this is not a valid possibility, because 7 digits at least add up to 28. But that would be a problem with the loop, essentially. So that's how internal xsums work. So again, remember, each cell with a number in the top left corner is on the loop. And the digit in that cell says how many cells it sees that are on the loop. So this would see, and it includes itself, so therefore this would see 5. Say this were actually a cell that had this internal xsum, then this would see, well, let's use this one. This would see 1, 2, 3, 4, 5, 6. So if that were an internal xsum, this would see 6 digits. And it adds up to the number in the upper left corner of the cell. The digits that add up. So that's how internal xsums works. Crop key pairs. Digits joined by a white dot are consecutive, and not all dots are given. So for example, if this were a 7, this would have to be a 6 or an 8 to be consecutive with it. And that's how white crop key pairs work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. So we know all the digits, all the cells with numbers in the top left corner must be on the loop. Now the trick, okay, so therefore, to get on the loop here, again, we're assuming it's orthogonally connected, because I think that's the only way that I've seen loops work, is that they have to be orthogonally connected. So therefore, this has to go this way. We know this cannot be on the loop, because then it would be considered touching itself, right? and it cannot touch itself. So it has to go this way then, and it has to go this way. So this has to be at least 5 because it could be the most you can have is 5 digits. We know it's 5 digits here, adding up to 5, 6, 7, 8, and 9. We know the loop cannot go through here. Oh, but it can't be 5. If it were 5, the problem is that you would have to have 6, 7, 8, and 9, adding up to the 35. But because of the Run-on-Nabner loop part, you can't have 5, 6, 7, 8, and 9 added up to that. Because 6 would be consecutive with it, and it would be within 3 of it, right? Um, hmm. So this has to be at least 6? Hmm. It could be up to 9, potentially. Hmm. One thing is, it cannot go this way along this these two cells, right? If the loop went this way, essentially, the problem is this cannot be basically the center of a cell. Um, because if it were, so it cannot be the center of a sequence, shall we say. Because if it goes this way, the problem is this doesn't have any other digits to add up to that this doesn't see. So this would see at least 19, or sorry, at most 19 in this direction. And then therefore this would have no other digits to see in any other direction. So this would be 19 at most, which is not possible because we know it's 28 for the digits that it sees on the loop. So this can never be on the loop. This could go this way though, so we don't know about that. The loop can never cross any of the um, Kropke circles because those are consecutive. And we have the Run-on-Nabner rule. What else do we know? So this one has to turn this way or go this way. We're not sure which. Um, this could go something like that. That's possible. Hmm. So again, this can't be 5. It can it be 6 is the question. Maybe you can't have 7 or 8 with it. So you could have 6, 9. You could have repeats too here, right? So it could be like 9 and 9 here. Oh wait, no, you can't have 5 or 7 if you have 6. Well, we know this is 6, 7, 8, or 9. If you have 6, you could have 8 and 9 with it. There's a lot of possibilities. We just know it can't be 5, though. Um, hmm. This again cannot be 4 because it would require that to be with 7, 8, or 9 in 4 digits. So this has to see at least 5. It could be 6, 7, 8, or 9 too. Basically, any of them could go up to 9 because of... It doesn't have to be like 9. It could be like 9 this way or something like that, right? Which would be possible then. You could have 5, 4, 3, 2, 1. Or 5, 3, 2, 1, 7. Is that possible? 5 plus 1, 2, 3 plus 7 is 18. 18 plus another... Actually, I would guess it would be 9, right? So it could be 9 with 1, 2, 3, 4. Okay, so this can't be 9 specifically. Because if it's 9, the minimum you have to add up to it would then be 1, 2, 3, 4, and 1, 2, 3, 4, which would be 29. So this can never be 9 then. It could be 8, because you could have 8 with 1, 2, 3, 4, and 1, 2, 3 is the minimum. So then that would be 16 plus 8, which is 24. Okay, so 31 and above can be up to 9. And it has to be at least 5. Right, because you can't have 4 digits adding up to 31. Actually, you could, actually. This could be 4. It could be 9 and 9, right? Oh, but that's 3 apart from each other. So no. It cannot be, yeah. So if you have 4, the problem is you can't have repeats within that 4. Because those are 3 apart from each other. Right? 1, 2, 3. But it could be 5 still. 28. You cannot have 4, 7, 8, and 9. The problem is the Nabner line would still work there, right? And you can't have 4, 9, 9 either. With 6, I guess it would be. Yeah, 4, 6, 9, 9 doesn't work either. 25 could be up to 8. And I think 4 does work there. How does 4 work as a Nabner line? You can't have 3 or 5. You can't have consecutive digits 4 along it. 4, 9, 7 adds up to 20, but then you would have to have a 5 there. So I don't think you can have 4 adding up to 25 either. Because you can't have repeats. If you have 4 digits, you can't have repeats all along it, and you can't have consecutive digits. So if you tried to have a 4, it would be with 7 or 9, or 6 and 8, or 6 and 9, but the problem is you would still require another 4 or 5 there, if that's the case, or 3. Right, if you tried 4, 6, and 8, that would be 18, that would require 7. Yeah, so this can never be 4. It could be 5 up to 8, though, here. 21's interesting, right? 21, you have to have at least 4. But you can actually make it work as a 4. You can't have 3 because that requires 3, 8, 9, and those 8 and 9 is consecutive. And that would add up to only 20 also. What about 4? 4, you could have like 2, 6, and 9 with it, and that does add up to 21, so this could be 4. It could be 5. You can't have 8, because if you have 8, you have to go 4 one way, at least, and 3 the other way. So then that would require 8 plus 1 plus 2 plus 3 in some order, and 1 plus 2 plus, and even then that's kind of iffy. Yeah, because if you have 1, 2, 3, 4, that doesn't work actually if you have an 8 that way, right? If you have 4, well, actually, you can't even have 1, 2, 3 in one direction. It has to be 1, 3, 5 at least. So one direction could be 1, 3, 5. I guess the other direction could be 1, 4, 6 with 2. Does that work? So if you have 8, you have to have 1, 3, 5 in one direction at least. I mean, you could technically have one direction, and then 6 in the other direction. Well, this one specifically can't. Um, it would have to have 4. It would have to have 4 in one direction and 3 in the other this is 8, because specifically because of the center cell, right? Because it can only go 4 in one direction. So then this would have to be 1, 3, and 5 at least. So that's 9. 9 plus 8 would be 17. And you could have 1 and 2 on the outsides, right? But that means you can't have 3 in between them. Oh, wait, no, you can't have 1 and 2 on the outside. If you tried to have 1 and 2 on the outside, the problem is they would be 3 away from each other. And they can't be continuous. So it would also have to be 1, 3, 5, and 7. Okay, so then that does not work. This could be 7 here, because this would not be 3 away. But they would have to be 1, 3, and 5 here, and that would be 7. So that would add up to 9 plus 9, which is 18, plus 7. Nine plus 9 plus 7. So it's 18 plus 7, 25, plus 8, which is 33. Yeah, so this can't be 8. It could be 7. 135 plus 135 is 9. So it's 18. So it's 25 at minimum. So this could be 7, actually, same way, right? Except that, well, if this were 7, it can't go across this way, right? So it would have to be, it would actually just have to be 7 across here, which doesn't work. Right, if this is 7 just across, the problem is that you would not have to have a 6 and 8. You can't have 7 going that way, because it can't, again, it can't cross this way. So it would have to be, if you had 7, you would have to have 7 essentially going this way in some order. So it's that 7, this is 7, or this is 7, right? And therefore it would be, it could not have a 7 in any of the rest. You cannot have 7, 6, or 8 in any of those cells, in the rest of the cells. So it would have to be specifically 1 plus 2. 1, 2, 3, 4, 5, 7, and 9. which is 15 plus 7, which is 22 plus 9, which is 31. So this can never be 7. Can this ever be 6? I'm not sure. You could potentially have duplicates. So it could go something like this to here. This is a possibility, or like this to here. If you have 6 in a row, that's possible potentially. So it could be 6 this way, then up, and then like that. That's possible. Hmm. Obviously, if it's 5 and it's just straight, it has to be one. Well, it doesn't have to be, but it probably is 1, 3, 5, 7, 9. So that works. Um, it doesn't have to be though, right? Because it's 3 away, and if you have 5, this is 4 away from the ends. So the ends essentially could have repeats or could be consecutive. So you could actually have a repeat there, possibly. That's why 6 could potentially work too. That's what I'm trying to think of. So this is 5 or 6. Either way, it's either 5 this way or it's 5 that way. Unfortunately, that doesn't tell us much. Oh, it cannot be 5 this way, though. If it goes 5 this way, the problem is that this also seems the same amount as this one, right? Or even if it's 6 this way. And the problem is that this would be 25 for those 5 cells at most. So this can never be, it can never just be in the middle. Similarly to this, it can't be in the middle of a run here. But the problem is it could actually go something like this, right? Or something, I don't know. It cannot touch itself, so this wouldn't, if it goes this way, it would have to go here. Oh. Ah. So, okay. That's one thing then. It cannot go this way because then it would touch itself if that's the case. And I'm assuming again this is orthogonally connected. Maybe that's a bad assumption. Uh, but if it does go up, it does have to essentially go that way because it would be touching itself otherwise. So then it would have to go there, but then it would be touching itself again, which is not possible. So this cannot go up, which means it cannot go 5 this way and then go up. So it cannot be 6. So this has to be 5 then. It can't go up here. We know that's not possible because then it touches itself twice in one way. So this cannot be 5. This has to be more than 5. It cannot go 5 here and then go, well. So then it cannot be these 5 because then it goes into blank. It can't be, it then has to connect this way. So it has to connect this way. This is always larger, so then it cannot go this way because if this were part of the middle, then we know that it adds up to 25 then at least. So it has to go this way, which means it must connect this way too. So this has to be 7 then, specifically, to add up to, and then this must be here. This cannot be part of the loop, so it must go up here. And remember, we're assuming the loop has to be orthogonally connected. Otherwise, it doesn't really make sense. So this cannot be 6 or 8. This is 7. We know these 5 add up to 25. So these 2 must add up to 6. So therefore, this is either 1, 5 or 2, 4. We're not sure which. This can't be 5, though, because that's 3 away. This can't be 4, because it's 3 away from this 5. Therefore, this can't be 1 or 2. This is 4 or 5. What could this be? 1, 2, 3, no 4, no 5, no 6, no 7, no 8. It could be 9. But this is 3, this cannot be consecutive with this. So if this were 2, this would be consecutive with 1. It would be a repeat or consecutive with 1 or 2. So this cannot be 2. This could be 1, 3, or 9. Again, there's no 4, 5, 6, 7, or 8 possible here. There's no 4, 5, 6, 7, or 8 possible here. So this could be 1, 2, 3, or 9 also. If this were 2, it would be consecutive with a 1 or 2. Or a repeat. So this is not possible there. This cannot be part of the loop because it would touch itself. Same here for any of these. Again, this would not be part of the loop. It could go... If it goes this way, it has to connect to here. So this can never be part of that. Well, yeah, this can never be part of the loop. Because then it would touch itself there and then go that way. It can never actually enter here. Because then it would be touching itself. Because once it goes this way, it can't go there. It has to go there because then that would be touching itself. This could be 6 or it could be 8. So this is 1, 2, 3, 8, or 9. Okay, but then the problem is this adds up to 12. These 3 digits add up to 11. Sorry, not 11. 13. And the only possibility, I think, is 1, 3, and 9. I mean, if this were 8 and this were 2, the problem is this would have to be 3. To add up to 13. And 3 and 2 are essentially are consecutive. Yeah, so this does have to be 1, 3, and 9. So this is 1, 3, and 9. This is 1, 3, or 9. If this is 1, this could be 3 or 9. If this is 2, it would have to be 9. So either way, it cannot be 1. Right? If this were 1, that would be next to a 1 or 2. That's 2 away, so that's not possible. If this were 1, this could be 5, and that could be 3, and that would work. This is 3, 4, or 5. Well, this can't be 4 or 5. No, this is 3 or 4. So it either goes here and goes up, or it goes here and up, and that's 4. So this is 3 or 4. If this were 4, that would be a repeat or be 2 away. So this cannot be 4. This has to be 3, which means it must go this way. And then it must go up. So this cannot be on the loop. This cannot be on the loop. This can't be just 2, because that doesn't work. Actually, it doesn't go that way. It would have to go that way if that's a possible. These can't be on the loop, because then it would be touching itself. This is 3, so this can't be 4. This has to be 5, which makes that a 1. This can't be 3, so this is 9. This can't be 3 or 9, so this must be 1, which makes that a 3. This must add up to 16, so this is already adds up to 8, so this must be 8. This is consecutive with 8, so this is 7. This can no longer be 7. It's 5 or 6. This can't be 5, so it must be 6. So it sees 2 other cells this way. Therefore, this sees 4 cells total. These cannot be on the loop. These can't be on the loop because it can't just enter it. And this is 6, we know. So this adds up to... This adds up to 19 here. So these two must be 9. And they cannot contain 3, 4, 5, 6, 7. So this has to be 1 and 8. So therefore this is 8 and this is 1. Right? Because it can't be 2, 7 because 7 is consecutive with the 6. Can't be 3, 6 because we already have a 6. Can't be 4, 5 because we already have a 4. So it has to be 1 and 8. This goes up. We don't know if it goes this way though. So this adds up to 19. Therefore, these two add up to 9. Because it's 28 minus 19. So therefore, this is a 1. Oops. This is a 1. This cannot be 9, obviously. It cannot be 2, because it always enters in as part of 1. So this has to be 3 or 4. If it's 4, it cannot contain a 3 or 5 with it. So if it's 4, it has to be 1 of 1 or 2. But the problem is it requires like a 6 and an 8 to be with it. Right? It cannot be 5 because then that would be 1 through 4 required. Pretty much. And therefore we have consecutive digits on the loop. What about 4? Well, it can't be 5 anyways because of this 5. So again, 4, you have to have a minimum of 1. So that's 5 already. And then you would have to have 2 digits that are 6 and greater, which add up to 10, which is not possible. So this has to be 3. Okay, what are the remaining digits here? 2, 4, and 6. So this is 2, 4, 6, and this is 2 or 4. Sorry, 2 or 6. The remaining cells here are 2, 4, 9. And this can't be 4 here. It cannot be 4 here, so this is 2, 4, 9 also. So it cannot go any of these ways, right? The problem with these going either of these cells on the loop is that 2 and 4 are essentially consecutive with 3. And if you had a 9 here with this 3, it has to add up with another 3 to add up to 15. So these cannot be part of the loop. Therefore, both of these are the loop. And you have to add up to 15. You cannot have a 4. So it has to be, sorry, yeah, all 3 of this must add up to 15. So one, and this one cannot be part of the loop. Therefore, this has to be part of the loop, which means none of these two could be part of the loop because it would be touching itself. This could go down or it could go up. We don't know. These 3 digits cannot contain have to add up to 15. So these 2 add up to 12. It cannot be 3 and 9 because we already have a 3. It cannot be 4 and 8 because 4 is consecutive with 3. Therefore, this must be 5 and 7. So this is 5 and 7, this is 5 and 7. If this goes this way, where does it exit out? It can't go here because these are consecutive, and it can't go here because this would touch itself. So this can never be part of the loop now. So this has to go this way, which means it's at least 7. The ones have to be here. And the ones have to be here. The ones have to be one of those two. What else is remaining here? This is at least 7 adding up to 35. It could potentially go down to 9. That's actually possible. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's possible. Or it could just go here, right? Oh, this sees 4 or it sees 5. Well, it cannot be the middle part to see 4. Again, it cannot be 3 then. This can't be 3. So it has to go this way. So we know both of these are part of it. And it has to go at least one here or one here. So this can never be 9 then. This is 7 or 8. It could be both of these, or it could be one of these and then this one, or one of these and this one. One thing we know then is none of these can be part of the loop. And this one can't be part of the loop because it can't enter in this way. It has to go to one of these two. Same with this one. It has to go to one of those two. So this can't be part of the loop. This is not part of the loop because it must go up or down. We're not sure which. So can this ever be 5 then? No, because it has to be 5 unique digits. And you can't have 5 unique digits form a Nabner. Well, maybe. Hold up. If this is 5, none of them can be 4 or 6. Oh. If you have a 5. Okay, so it cannot go this way, because if it goes this way, again, the loop would have to go through here, which would mean these two digits are consecutive, which is impossible. So this cannot go this way, which means it does go this way. It has to continue here and then continue on to here. So then we know this cannot be on the loop. Yeah, I think you have to assume that the loop is orthogonally connected because you can't. I think it just becomes way too hairy and nearly impossible to actually figure out where the loop could be, right? No, maybe not. I don't know. You sort of had to do that. Well, maybe you could do that way and then go up here and then down here and then some funky way that way. Or I guess it could be like that, there. Or, yeah, it just becomes really funky if you assume assumption that you've never seen before, right? Yeah. Anyway, the rest of these cells are what? 2, 3, 5, 7, 9. Yeah, this is 2, 3, 5, 7, 9. This cannot be 5, because if it were 5, that would be consecutive or the same as that digit, so this can't be 5. What are the remaining digits in box 2? We know the 4 has to be one of these two cells, so none of them can be 4. This could be 1. This could be 1, obviously. This could be 1. It cannot be 2, 3, 4, 5, 6, 7, or 8. And it can't be 9 because of this 9. So this has to be a 1. Right? Because it has to be not consecutive with 5 or 7 either. Because it sees both of these cells 3 digits away on the loop. So 5 eliminates 4 and 6 also. 7 eliminates 6 and 8. And 2 is eliminated by the 3. So 5 eliminates 4 and 6. 7 eliminates 6 and 8. And this can't be 9. So therefore this has to be 1. What is this cell in the loop? It cannot be 1, 2, 3, 4. It could be 5, but this is not 5. It could be... This cannot be 6 because that would be consecutive with 5 or 7. Can't be 7. It can't be 8. This has to be 9 then, right? 1 through 4 is eliminated because that's consecutive or the same as 1 and 3. This can't be 5. It can't be 6 because that's consecutive with 5 or 7, whichever one it is. It can't be 7. It can't be 8 because of the digits there. Therefore, this must be 9. Okay. This can't be 1, 2, 8, or 9, but it could be any of 3 through 7, so that's fine. This can't be 7, though, because that's consecutive with 8, which is 3 away from. This cannot be 1, 2, 3, 4, because 1 and 4 are the same, and 2 and 3 are consecutive with 1 and 4. It cannot be 5. It could be 6. It cannot be 7 or 9. So this must be 6 then. 7 or 9 consecutive with 8. So this can't be 6. It can't be 5. It has to be 4, 3 here. This cannot be 1 because we have a 1. It can't be 3, 5, or 7. And it cannot be 2, 4, 6, or 8 because that's consecutive with 3, 5, and 7. Therefore, this must be a 9. So this is a 9, which forces this not to be 9. Or this 9, we have a 2, 4 pair now in column 5, which eliminates 2 and 4 from the rest of the column. So this must be a 9, which means this can't be 9 either. The remaining cells here are 6 and 8, but this can't be... this could be 6. Okay, 6 or an 8, 6 or 8. So this is a 9 here, which means this cannot be consecutive with this digit because it's 3 away. Therefore, this must be 7. Since this is 7, it cannot go this way. So this is not allowed. It has to go here because it only sees 7 digits here. Okay. This cannot be consecutive or the same as these digits. So that eliminates 1 through 6. It cannot be 7. This has to be 8 or 9. We're not sure which. This cannot be the same as 3 and 9 or 7. And it can't be consecutive with anything. So that's cannot be 6 through 9. It cannot be 2, 3, or 4. So this is 1 or 5. This one could be, it cannot be 6 through 9, but it could be any of 1 through 5. Okay. 9 has to be one of these 3 cells. These can't be 6 or 8 or 7. So, but it could be 1, 2, 3, 4, 5, no, 6, 7, or 8. It could be 9. So this can't be 1 or 9 here specifically. This can't be 3 specifically. So you could have a repeat here, and you could have a 9 here. That's possible. Can you have a... So... What happens if you don't have a 9, actually? This then could be 3, 5. This could not be 3 or... Okay, so that's interesting. If you don't have... Okay, this can't be 5 either. So this would be 1... If you don't have a 9 in either of these spots, this would have to be 1, 3, 5. Because they would have to be mutually non-consecutive here. So that would add up to 9. So you would have 9 plus 9 here, which is 18, plus 7 is 25. And then you would have to have these 2 digits add up to 10, which would require a 9 here. Okay, so then this can never be 9, right? Sorry, this has to be a 9. If this is not 9, say this wasn't 9, again, this has to be 1 through 5. That adds up to 9, plus 9, plus 7. So 9 plus 9 plus 7 is 25. Because it's 18 plus 7. Therefore, these two would add up to 10, but that's not possible because of the digits possible allowed. So this then has to be 9. So this is a 9. This can't be 9. These 4 digits then must add up to 10. Hmm. We're not sure what that is, though. Okay, so what are the remaining digits in column 7? It has to be 2, 3, 4, 6, and 7. 2, 3, 4, 6, sorry. This can't be 6, so this is 2, 3, 4, this is 2, 3, 4. If this were 2, this would have to be 1 or 3, but that's not possible because of what's already there. So this can't be 2. If this is 3, this would have to be 2 or 4, so it could be 2 and 3 here. If this is 4, it would have to be 4 and 5. So either one of these works. If this is 2, it would have to be with 3 here, because the 1 is not possible. If this is 3, it could be 2 or 4. That's fine. If this is 4, it could be 3 or 5, so that works. If this is 6, it could be 5 only, and 7. Where is the last possible 7 in row 3? It can't be any of these, it can't be any of these, and it can't be these. So it must be here. So this is a 7 here, which means this can't be 7. This specifically cannot, if this is 3, this cannot be 4, because that would eliminate all possibilities for that cell. If this is 4, though, it could be 5. But this can't be 4. If this were 4, this would have to be 3 then. So this can't be 4 here. We know the 6 is one of these 2 cells. The rest of these cells are 2, 4, 6, and 8. This is 2, 4, 6, and 8. But this can't be 6. Okay. I mean, yeah, the simplest one is that this is 1, 2, 3, 4 here, right? So then this would be, oh. This would have to be, these can't be consecutive. You can't have 1, 2, 3, 4 then. So say you had 1 here, and this was 2, 3, 4. The problem is 3 can't be with 2 or 4, so it cannot be here. So this would be 3, but the problem is 2 or 4 would be here then. So if this tried to be 1, 3 with 2, 4, 2, 4, that doesn't work. And you can't have 1, 4 either here, right? So obviously, okay, you can't have 1, 2. You can't have 1, 1. If you try 1, 3, that has to be with 6. I guess it could be 5 and 1. So that's possible. So 1, 3, 5, 1. So 1, 3 is possible here. 1, 4 is not. Because these would have to add up to 5, and you would have to have 2 and 3 and 2 and 3 together, which is not possible. So this can't be 1, 4. Cannot be 1, 1. Cannot be 1, 2. Could be 1, 3, as long as this is 5, 1. So this could be 1, 3, and as long as this is 5 and 1. It could be, cannot be 1, 4, because then that would require these be to add up to 5. If therefore it would be 2, 3, 2, 3, which could be consecutive. It could potentially be 1, 5. If it's 1, 5, this has to be 1 and 3. So this could be 1, 5, and then this is 3, and this is still 1. What about 5 and 2? Then this would be 1 and 2, which is not possible. And then 5, 3 doesn't work because, yeah, so this has to be 1, 3, 5. This has to be a 1 then. This can no longer be 2 because that would be consecutive with 1. These remaining cells now are 2, 4, 6, and 8. Well, we have a 2, 4, 6, 8 triplet. Quadruple in row 3, which eliminates 2, 4, 6, and 8 from the rest of the row. Therefore, this can't be 2, 4, 6, 8. This must be a 3, which makes this a 5, which makes this 1, which makes that a 3. Okay. This has to be an odd digit. So it's 1, 3, 5, 7, 9. But 1, 5, and 9 cannot be here, and 3 can't be here. Therefore, this must be a 7. So none of these are 7s. Where is the 7 in row 5? It has to be here. So this is a 7. This can't be 3 anymore. This has to be 9, which means these can't be 9. How do you add 5 digits together? You can't, right? Because they have to be all in the same row. This is 14. This has to be 4, which forces this to be 1, which means that's consecutive with a 2, right? This is 20, so this is 21. This has to go this way. So this is not on the loop. This is 1 and 2, so this can't be 2. This can't be 2, and this can't be 2 or 4. These can't be 4. We have a 2, 6, 8 triplet now in column 2, which eliminates 2, 6, and 8 from the rest of the column. Therefore, this is a 5. 7's consecutive with only 6 or 8. We have a 6, 8, 6, 8 pair in column 2, which eliminates 6 and 8 from the rest of the column. Therefore, this is 2, which means this can't be 2. We have a 6, 8, 6, 8 pair in row 3, which eliminates 6 and 8 from the rest of the row. So this must be 4, which makes that a 2, which makes that 4. This cannot have a 3 or 4. Well, 2 is no longer consecutive with anything here. So this can't be 2. This must be 6 and 5. That 6 means this can't be 6, so this is 8, which makes that a 6. Neither of these can be 6, so therefore this must be 4. That has to be 2. This has to be 6. This again cannot be 6. This can't be 3 or 2, so this must be 4. This can't be 4. This can't be 4, so this is 3, which makes this a 2. This can't be 3 or 4, so this is 2. This can't be 2 or 3, so this is 5 or 9. This can't be 9, so this is 5. This can't be 2 or 5, so this is 3. This can't be 3 or 5, so this is 2. This is 6 or 8, 6 or 8. This can't be 2. This has to be the last remaining 2, so this is a 2, this is a 1, this is an 8. Because it cannot be 6 here. This can't be 6, this is an 8, which makes that a 6. This can't be 8, so this is 6, which means this can't be 6. This can't be 6, and this can't be 2. Where is a 2 in row 9? It has to be here. So this is 2. This has to be, what, 6, 7, or 9? Yeah, the remaining cells here are 6, 7, and 9. This can't be 6, this can't be 7. This can't be 6. So this is 7 or 9. If this were 8, that would be consecutive with both of those. So this cannot be 8. This has to be 9, which makes that a 7. That makes that 9, which makes that 6. This is a 4, 8, 4, 8 pair. This can't be 6, so this has to also be 4, 8, which makes that a 6. This is 3, 4, 8, but this can't be 3, so this is 3. This has to be 4, 8. But this can't be 8 anymore because of that 8, so this is a 4, which makes this an 8, which makes that a 4, which makes that an 8. And now we're just doing Sudoku, so this is 5 and 8, but we don't know which one. This can't be 7, so this is 5, which makes that 7, which makes that a 5. So this can't be 5 anymore, so therefore this is 8, which makes that a 5. We have 8 and 3 remaining, so this can't be 3, so this is 8, which makes that 3. This is 7 and 9, so this can't be 9, so this is 7, which makes that a 9, and therefore this is a 4. And that's how you solve it. Yeah, I wish we had more clarification about the loop specifically, because it would have been nice to know that it guaranteed to be orthogonally connected. But I think just there are too many possibilities if you start allowing diagonal connected loops for this to really work. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.